What is a geometric distribution? Geometric distribution is a discrete probability distribution of a random variable x that satisfies the following conditions. First of all, a trial is repeated until you have a success. 2, the repeated trials are independent from each other. 3, the probability of success P is the same for each trial. 4, the random variable x represents the number of trials in which the first success occurs. The probability that the first success occurs on trial number x is P of x, which is P times Q to power x minus 1. And remember that Q is 1 minus P. Let's take a look at one example together. Basketball player LeBron James makes a free throw shot about 75% of the time. Find the probability that the first free throw shot he makes occurs on the 3rd or 4th attempt. To find the probability that he makes his first free throw shot on the 3rd or 4th attempt, we need to find the probability that the first shot he makes will happen on the 3rd attempt and the probability that the first shot he makes will happen on the 4th attempt. Then find the sum of these two probabilities because we have or in between them. The probability of success is 75%. The probability of failure is 25% and x is 3. So let us follow the formula. P of 3 is P, which is 75%, Q to power 3 minus 1, which is 0.046875, about 5%. The probability that x is 4 is 75% times Q, 25% to power 4 minus 1. Now our x is changing to 4. This is our exponent. So it is about 0.01, so it is now smaller. So the probability that shot made on 3rd or 4th attempt is the probability that x is 3, or the probability that x is 4, which is about 6%. So this is the definition of geometric distribution, the probability, and then one example for you. Now I expect you to ask, what is the expected value for geometric random variable? Expectation of a geometric random variable. To calculate the expectation of a geometric random variable, E of x is the summation of n, p, q to power n minus 1. Q is 1 minus p. And remember that the expected value was defined as the summation of x times p of x. And in the previous slide, we introduced p of x for a geometric distribution. Well, your p has nothing to do with n, so you can factor out p, write p outside the summation Riemann sum. So the expected value can be written as p times the summation of, but from calculus, this guy is nothing but the derivative of q to power n. So basically, you can simplify this as p times the derivative of the summation of q to the n starts from 1, goes to infinity, which can be written as p times the rate of change of q divided by 1 minus q. This is just a geometric sum. So when you have a geometric sum, the summation is q divided by 1 minus q. So you can simplify this to p divided by 1 minus q to power 2. We just took the derivative of this quotient and it becomes p divided by 1 minus q to power 2. And you can simplify this to 1 minus p. P divided by p squared is 1 minus p. So the expected value for geometric random variable is 1 minus 1 over p. So the summation of I times the probability that x is more than equals to I is the summation of i's times 1 minus p to power I minus 1, which can be written as 1 over p, the summation of i's, 1 minus p to power I minus 1. This guy is 1 over p times the summation of i's times the probability that x is exactly I, which is 1 over p times the expected value of x. This can be written as 1 over p divided by p, or 1 over p squared. So the expected value of x squared is 2 over p squared minus 1 over p. And the variance, as you remember, was equal to expected value of x squared minus the expected value of x to the second power. So basically, the variance of x is 1 over p squared minus 1 over p, which is 1 minus p over p squared. So we found two important pieces of information. One of them is the expected value, and the other one is the variance for the geometric random variable x. Expected value, 1 over p. And here you have your variance, which is 1 minus p, divided by p squared.